All right. You guys should be able to hear me, but I'm recording this in hopes that you guys will be able to find some use in this. A good amount of you have already started preparing for the test, which is very impressive, and you guys are getting pretty ahead than we are in lecture. So good job, you guys. But let's go ahead and just take a look at some practice, especially for the review session, to just supplement some of that. So for this first part, we are going to be taking a look at some naming, mainly cyclic naming, because a good amount of people have had some trouble with that. And there are some distinctions that should be known. I will say that once you do get it, you kind of get it. It's just one big hurdle that once it all comes together, you should be fine. But with that being said, let's go ahead and move on. I'm going to be sharing my screen. And all right, you guys should see my screen right now. All right. And sometimes the technology will bug out on me and I might just have to like reconnect things. So please work with me. All right. But this thing should be posted pretty soon, but let's take a look at this. This is something I already worked out before on some of my office hours, but let's just take a crack at it. So when it comes to naming, there are these statuses known as priority groups and branch status groups. Well, that's what I call them. So branch status means that, all right, they are all in the same playing field and we just want to denominate numbers that give us the lowest possible combination. That's what you know, that's what you've been working with. However, these priority groups right here, the moment these come into that compound, they get priority and basically jumble everything up. The main premise is the moment that an alcohol or an amine comes on the compound, they have to get the lowest priority no matter what. And we will have more practice with this. All right. And for semester one, the highest you'll get is alcohol. And the main two you'll be dealing with is amine groups and alcohols, but alcohol is the top dog. So it's a pretty safe bet to say that the moment you see an alcohol, it's going to get like the suffix OL, like hexanol, cyclopentanol is going to be an all compound. And as we get to the later test, we will introduce alkenes and alkynes into enols, but name wise, it's just a short addition. It's really easy, but I'm getting a little ahead of myself. So with these in our minds, let's go ahead and just move forward. All right. Because hopefully you guys took a look at that the info sheet I shared, and we'll just crack into practice. Now for this problem right here in the top right, we all have chlorine, bromine, methane, a methyl group. All right. They're all branch status branches. So from what we normally been doing, we just want to number them in the same way we've always been numbering them, in the shortest possible route. And this is where I should introduce this concept called the first point of difference. And I think it's super important. All right. So the first point of difference is basically, all right, if we have a cyclic compound and we have two branches right next to each other, pretty much always you're going to be starting from there. All right, is one of those two, you're going to be starting from there. All right. And if you start at one, let's just hypothetically, I know, barring alphabetical priority, anything, let's just start at chlorine, right? If we start at chlorine, well, there's two ways we can go, left or right. But the thing with the first point of difference, the main thing we do know is that if we start at one point of a pair, we have to go the direction where the other branch starts. So this has to be 2 if chlorine's 1. And vice versa. Okay, let's say we're getting serious about naming this. Let me erase that. All right. And let's start at bromine. Well, if we start at bromine, we have to go this way, 2, 3, 4, 5, and all that stuff. So that's kind of the gist. However, remember, alphabetical priority only happens when we're trying to break a tie. But for here, there's no tie at all. And just by practicing and looking at it, hopefully you guys can recognize, well, the shortest path to cover the branches and give it the lowest number possible is going counterclockwise, starting from chlorine, 1, 2, 4. Because if we start at the methyl group, 1, 3, 4, 1, 3, 4 does not beat 1, 2, 4. Same thing, start at bromine, 1, 2, 3, 4, 5. 1, 2, 5 is even worse. But this is a pretty simple problem. Let's move on. Oops, I just erased that. let's move on over here. So for this problem right here, we have 4 branch status groups, and this is something that you will see ETO or MEO. These just denote ethers. So ETO would equal CH3CH2O and whatever R group is connected to, because it's supposed to stand for ethoxy. Same thing with MEO, that's methoxy. I'm not writing an M, CH3O, like that. So that's a really good notation that you will see in both semesters. Write that a little neater. All right, ETO, that's just an ethyl or ethoxy group. And remember, going back up to here, an ether is branch status. No matter what, they're all in the same playing field. You have an alkane group, ether group, and then all the halogens here. Let's go back down. So getting from here, we know that we need to start from either here or here. And that kind of makes sense because if you start from here, you number that way, we pretty much hit branches all across. And same for here. If we go here, we give 1, 2, 3, 4 tetrasubstituted alkane ring, which is what we want because we get really low numbers. Because if we went the other way, like we start from here and go that way, we have blank carbons that we're running into that get basically increase those number denominations, which is what we don't want. So, okay, if we start from here or here, that's where we know where we want to start. But if it can go both ways, like if we have 1, 2, 3, 4, and then the other way, 1, 2, 3, 4, well, that's a tie. And what's our tiebreaker? That is, or excuse me, our tiebreaker is alphabetical order. And chlorine, last I checked, C comes before E in the alphabet. So it would be 2 bromo. Oh, whoops, my bad. 3 bromo. I know I'm doing it red. Let me keep it consistent. 3 bromo. 1, 2 dichloro. I'm just doing 3 dots just to keep it going, but there's no actual space. Dichloro, 4 ethoxy, cyclohexane. It should be an L. I'm sorry about that. Okay, cyclohexane. Now let's move on to the cyclopentane. Now let's reapply that concept of the first point of difference. We see, all right, this should ring the bell. 2 branches next to each other. So let's move on. If we must start at one of these, which way do we want to go? Because if this is 1, 2, 3, 4, all right, and this is 1, 2, 3, 4, 1, 2, 4 both ways. So we have to start at the most alphabetical, we have to prioritize the alphabet because they're a tie. So in real life, we start here, 1, 2, 3, 4. Remember, first point of difference. All right, we have to start at one of these. And if we go either direction, well, only one direction gives us another branch. So we want to start another pair. All right, let's go over here. Just some more practice for the first point of difference. Okay. And if you're wondering why this has some doodles on it, I was going over this with some previous students in office hours. So I apologize for that, but I'm cleaning up and just making sure you guys have it available if you were not able to come to office hours. For this one right here, all right, we have another tri-substituted alkane ring. Where do we want to start? Well, first point of difference, right? We have to look for these di-substituted things, and then we just have to work our way around. So if BR was here, all right, here or here. And the thing is, all right, well, if we started BR, we'd want to go this way to iodine, which you are correct. However, we started iodine, and we went through this way, counterclockwise and run through BR. 1, 2, 3, 4. Our ethyl branch gets a lower number compared to 1, 2, 3, 4, 5. Right? Okay. Let move this over here. let's take a look at this tri-substitute thing. We have a 1, 2, 3, not 1, 2, 3, 1, 3, 5, 1, 3, 5 tri-substituted alkane ring. And it's 1 through 5 all the way around, no matter where you go. So you have to think, all right, if these are going to be 1 through 5, where do I start? Well, if they're all tied, you have to start at bromine. Okay. For this one, it's not a 1 through 5 tri-substitute, but it is a 1, 2, 3, 1, 2, 3 di-substituted alkane ring. Substituted meaning the branches, by the way. And if it's a tie both ways, start with bromine, go that way. First point of difference. Now, yeah, this one's not too different. Actually, I thought it was. My bad. Right here, CH3, if we started here at this 1, 2, 3, 4, we would get the lowest numbers possible. Because again, we have two branches next to each other. More than likely, we're going to start there. All right, if we start at CH3, first point of difference, right? Go either way. Well, this gives us the first branch, so let's go that way. That's our first difference point. Okay, now let's throw in a wrench in the hammer. Let's introduce our priority group. So we've dealt with the branch status stuff, and hopefully you guys have enough practice. But remember, the moment we throw an alphabet priority group in there, we have to play with a few different rules. No matter what, that priority group becomes carbon number 1. Even if, all right, normally your instincts are telling you, okay, from what I know, let's start at CH3, first point of difference, right? The lowest numbers possible, if we get the lowest numbers possible if we go this way, 1, 2, 3, 4. So like that. But that is not the case because OH does not have the lowest number possible. The lowest number possible can be denoted to OH if we start there. So that's what we have to do. And I know it seems really weird, but it just keeps them consistent. And the moment we have, or the more we have more complex function groups, like you'll see in semester 2, it's pretty good to keep in mind that hierarchy, and it comes in handy. So make sure you know these rules because test 1 is super big on nomenclature. So we start at 1 at OH, always. OH has to be your first carbon in a cyclic naming system. Well, if this is 1, that's all we have to start with. Let's just play with the rules we've been going with now. So if we know that this has to be 1, let's just play by the rules like we normally do doing. First point of difference, we go either way. CH3 is our first point of difference. So we have to go that way. So this has to be 2, 3, 4, 5. So we have a starting point and we have a direction. So that's pretty easy. Let's go ahead and name it. We haven't done any of that, and that's pretty bad one. Let's go ahead and name it. 5-bromo. Oh, excuse me. 5-bromo, 2-methyl, cyclopentanol. And it's really good habit just write that 1 there, but or it's a good habit just in case, if you have an alcohol that's not on the first carbon, you have to have it there. It's just a good habit. Now let's throw an amine in there. Now, if there's no alcohol present, amines are priority groups. So they also have to be number 1. All right, let's do that. All right, if this is an amine, NH2 or an NHR are being any kind of alkane. So like NHCH3, that's an amine. All right, this has to be carbon number 1. Well, which way do we go? Because there's no adjacent branches here. Well, if we were to write it out, let's go both ways. 2, 3, 4, 5. 3 being on chlorine, 4 being on bromine. Let's go the opposite direction. 2, 3, 4, 5. 3 being on bromine and 4 being on chlorine. Well, it's 1, 3, 4 both ways, but 3 being on bromine gives it alphabetical priority, which is kind of what we want if there's a tie again. So let's go that way. So 3-bromo, 4-chloro. And this is the kicker. All right. N-methyl, cyclopentan 1. Look, it's so long, I don't even have room. Pentan 1 amine. That's how you denominate stuff. You there's a good chance you will see this on your test, an alkyl group attached to an amine. And you have to denote that somehow. I'm like, how do I denote it? Where's the locant? Well, the locant's right here. It's N. So if our nitrogens are locant, then that's what we write. It's, yeah. Now, here is a real hard one. All right. This one is a really good test on what you know. Okay. So, all right. We have two priority groups, an alcohol and an amine. And you might be thinking, all right, well, first off, let's just go with what he just told us. We have to start an alcohol, which you're right. Let's start at either one of these alcohols. You might be thinking, all right, well, once we start an alcohol, like let's start at this one, let's go this way. Because, first point of difference, if we start here, we get lower number of combinations if we go here. So we get 1, 2, 3, 4. Compared to if we started here, we get 1, 2, 3, 4. Oh, wait, no, never mind. Scratch that. We're getting there. It's correct. Don't worry. The reasoning is wrong. But nonetheless, the moment that alcohol is here, NH2 becomes branch status, just like any other branch, as if it was Br. And the thing is, if you have two alcohols, that's your direction. The moment you start at one alcohol, you have to go in the direction of the other alcohol. If you started here, you'd have to go this way. But if we started here, 1, 2, 3, 4, this goes in the direction of the other alcohol and gives us the lowest numbers. So this is correct. Compared to 1, 2, 3, 4, if we went this way, or 1, 2, 3, 4, if we went that way, starting at the other alcohol. All right, so let's go ahead and name this. This would be, remember, NH2, you can't have two suffixes. It becomes branch status, so we use the prefix amino. All right, for amino, cyclopentane, 1, 3, diol. I remember when we have diols or diamines, excuse me, we have to retain this E. All right. Even if it's triol or tetraol, we have to retain the E. The only time we drop the E is if it's just one ol or one amine. All right. I know it's kind of tough to wrap your head around, but just practice, and expose yourself. It will really help. I raised this one a little badly earlier, but let's take a look at this crack now. Well, going with what we started, well, we notice we have priority groups, so we have to start there. Either we start here or here. And again, your instincts might be telling you, all right, well, if we started here, 1, all right, if we went this way, we would give the lowest numbers to bromine and iodine, 2 and 3, because that's what we're used to. But you can't go that way. You have to go the way that gives the alcohols the lowest numbers possible, period. So we have to start here, 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6. So we have 4 and 5 against 5 and 6. Which one wins? It's going to be the red one. So we're going to have, whoops, 4 bromo, 5 iodo, cyclohexane, 1, 3, diol. Hopefully you guys are getting this, because that's kind of a distinction. Because let's just recap real quick. The moment a priority group is there, everything else becomes a branch status. All right. If it's all just branch status compounds, just give the lowest numbers possible. But alcohols and amines throw wrenches into everything, and you just have to be aware of that. Now let's take a quick practice where we don't have cyclic compound. We just have a normal alkane ring, or not ring. I just said not ring, alkene chain. All right. We have this compound that is on one of your problem sets, I think is from group 2. Let's identify our parent chain. All right. No cycle, just a parent chain. That would be this parent chain. It's going to be a butane. Remember, even though it can cross corners, which is something that he will throw at you at the test, like this way, if we made our parent chain 1, 2, 3, 4, this entire thing would be a branch, and that's kind of hard to name. So this butane, that's our parent. Now, this is denominated or number it. 1, 2, 3, 4. All right. That gives us the lowest numbers possible, 1, 2, and 3. Well, that's the thing though. We went the other way, 1, 2, 3, 4. It gives us 2, 3, 4 compared to 1, 2, 3. Your instincts tell you we got to go with 1, 2, 3. But that's the thing. There's an OH there. If an OH can be denominated as 2 or 3, it's got to be the lower one. So even though it does not make sense, you got to go with the 2. So it's going to be, all right, 4-methoxy, 3-methyl, butanol. Oh, butan-2-ol. See, there you go. That's the name. So hopefully this gives you a little more practice. I'm gonna record another video for the review session stuff, give you guys a little more practice on the content that we have learned thus far. So if you have any questions, feel free to email me, but that should be it. Stop my share. Let's stop the recording.